All right, ready for page 2? This is an introduction to what we're doing today. So, 1 over 1 is 1.0. 1 over 2 is 0.5. 1 over 8 is 0.125. 1 over 27, I don't know that in my head. What is it, people? 0.37? And it stops there? Oh, so all three of those numbers keep repeating?
Yeah, and then they terminate too. And then they terminate 3 times.
I think it repeats forever. Okay. How about 1 over 55? 0.18? And then 1/8 keeps repeating? Okay. And 1 over 400, 0.0025. Okay, very good. So the reason that we're doing this is to get something visual to look at to answer this question. So we have this fraction, these are all fraction, as the denominator grows bigger, what happens to the overall value of the fraction? It gets smaller. Now, it gets smaller and smaller and smaller. What if we went all the way to infinity? If the denominator got infinitely large, what would happen to the value of the fraction? It would get infinitely small. In fact, we could say it's approximately 0. Okay? And this is going to be very important for us as we study horizontal asymptotes and oblique asymptotes. Okay? This leads into something called limits and limit notation. Okay, next. Let's fill out this table. 5 squared is 25. 10 squared is 100. 50 squared, is that 2,500? What's 125? Hold it, 15,625. And then 250,000. And then, I know this, 16,483,600. Because I've already done it. I wrote it. I have a cheat sheet right here. See? Because sometimes I like to see if you're paying attention. Yeah. It's teacher trick. It's a teacher trick. Are you paying attention, Elijah? Yeah, you are. So you're good. Okay, now let's do cubed. 5 cubed, I know that one's 125. I'll just write them in here. 10 cubed is 1,000. These I know in my head. The rest of them, not so much. 125,000. 1,953,125. And then 125 million. Okay, I don't want to be greedy or nothing, but if I win the lottery, that's the number I want right there. Because I think that it has a nice ring to it. You want $125 million. Yes. It's perfect. Although I would take any of these amounts, quite honestly. Okay, 4060 cubed is 6.7 times 10 to the 10th. I would take that one too, but I don't want to be greedy. All right, so here's the question. This is why we do this, and this is really why we talk about this. You know, things get infinitely bigger, but infinity can have different sizes, which is crazy, because some infinities can be bigger than other infinities. And so, as x gets bigger, x squared gets bigger and x cubed gets bigger. But do you notice that they get bigger at different rates? And if we think about like which grows faster, which grows bigger the fastest? X squared, or x cubed? X cubed does. Yeah. So when the numbers are small, x squared and x cubed are kind of all in the same range on the number line. But when x gets big, x squared and x cubed are in completely different areas of the number line. You know what I'm saying? It's like, yeah, it's like they're different. Okay? All right, and that's going to be really important too. Okay,